Okay, hello everyone. My name is Zidni Ilma Sadelmi with number student 14012242279. Today, I want to explain about optimization without constraint of two variables. The definition of optimization without constraint is an optimization of a function without any specific condition that limit it, so that it can be said in achieving the best result either by maximizing or minimizing without considering the existing constraints. The optimization two variable can be used when first the company produces two kinds of products. The second is the cost of both are combined production costs. And the third is the maximum profit is calculated using a differential approach. And the value of maximum and minimum points, the function y equal fxz will reach an extreme point if dou f per dou x equals 0 and dou f per dou y equal with 0. And the point will maximum when dou square f per dou x square and dou square f per dou y square smaller than 0, and will minimum points when the dou square f per dou x square and dou square f per dou y square bigger than 0. And this is the example of the topic. TC equal with 5Ka square minus 30Ka plus 4Kb minus 3Kb square plus 7Kb. The question is whether the function of the variable is maximum or minimum. Okay, so first we must search the stationary point with the first variative. So first find derivative. So dou TC per dou KA equal with 10 KA minus 30 plus 4 KB. Dou TC per dou KA equal with 0. So 10 KA minus 30 plus 4 KB equal with 0. This is the first point. And then dou TC per dou KB equal with 4Ka minus 6Kb plus 7. And dou TC per dou KB equal with 0. So the 4Kb aka minus 6Kb plus 7 equal with 0. And this is the second point. So we must eliminate point 1 and 2. Ten Ka minus 30 plus 4 Kb equal with 0, and 4 Ka plus 7 minus 6 Kb equal with 0. And then we must, this is times with 3 and this is times with 2. So 30 Ka minus 1990 plus 12 Kb equal with 0. And then 8 Ka minus 14 plus and minus 12 Kb. Then we eliminate. This is over. This is 38 Ka minus 76 equal with 0. 38 Ka equal with 79 Ka equal 79 per 38 Ka equal with 2. And then we substitute for search the Kb for the Kb. Substitute the point of 2. Substitute 2. 4 times with 2 plus 7 minus 6 Kb equal 0. 8 plus 7 equal with 6 Kb. 15 equal with 6 Kb QB, and then 15 plus 6 equal with QB equal 5 per 2, and this is the value of QB. And then so the TC at this point is TC equal with 5 times 2 quadrat minus 30 times 2 plus 4 times with 2 times with 5 per 2. 2. And then 2 minus 30. 5 per 2 quadrat plus 7 5 per 2. So this is equal with 20 minus 60 plus 20 minus 18.75 plus 17.5. So TC equal with minus 21.25. So we must check the stationary point that maximum or minimum with divide the second derivative. So check the stationary point maximum or minimum. With divide the second derivative. Derivative. So the quadraticity for the QA quadrat. So we check all this. The second derivative is 10, and then the quadraticity for the QB quadrat equal with 4, right? 6 minus 6. Okay, minus 6. And then the quadraticity for the key A, key B equal with, and this is when the dog key A is, so we must check the key B 4, and when in the key B we must check the key A QA, and they're same. So the quadraticity per the QA QB is 4, and the D equal with the quadraticity per the QA quadrat times the quadraticity per the QB quadrat minus the quadraticity per the QA QB. equal times with minus 6 and minus 4 quadrant. This is quadrant. Then minus 60 minus with 16 equal with minus 76. So the D is minus 76 smaller than 0. So the TC is maximum at QA2 equal with 2 and QB equal with 5/2. Okay, that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Hello, my name is Rintan Azkia, NIM 140122456. I will explain about partial differential elasticity. There are two parts of elasticity. The first one is price elasticity of demand. The percentage change in the quantity demanded of a good divided by the percentage change in the price. Second is price elasticity of supply. Measures the responsiveness to the supply of goods after a change in its price. The value of elasticity divided into two. The first one is absolute value. When E is more than 1, it is elastic. It means the percentage decrease in demand is greater than the percentage increase in price. When E is below than 1, it means the percentage decrease in demand is smaller than the percentage increase in price. When E is equal to 1, it is unitary. It means the percentage change in price demanded is the same. The second one, there is original value. When EP is greater than 1, it means positive. The addition of delta x causes an increase in the value of y, and if x decreases, y also decreases. When EP is smaller than 1, it means negative. An increase in x causes a decrease in y, and a decrease in x causes an increase in y. Next is price elasticity of demand. For delta x equals demand change and delta y is price change. For very small change in demand, delta x becomes 0, so the elasticity of demand becomes a limit model, and the formula is become EP equals P per x times dx per dp. This proves that the elasticity of demand measures the percentage change in the amount of goods demanded by consumers as a result of a percentage change in price. Next is the question for price elasticity of demand. The question is, the demand function for a goods is Q equals 150 minus 3P. Calculate the elasticity when P equals 30. So, P is 30. And we need to find Q. Times 30 is 60. N if P per Q times the Q per Q is, this is dq per dp is the first derivative from Q equals 150 minus 3. P is 30 times the first derivative is minus 3. The result is minus 1.5. E is greater than 1, so it's elastic. When the price is increased 1%, it will cause the decrease of demand 1.5%. Next is price elasticity of supply. It is the same as the elasticity of demand. Delta X means supply change, delta Y is price change. For the small change in supply, delta X becomes 0, so the elasticity of supply becomes a limit model, and the formula is become EP equals P per X times dx per dp. This proves that the elasticity of supply measures the percentage change in the quantity supplied by the producer as a result of a percentage change in the price of goods. Next is the question for price elasticity of demand. The supply function of goods is stated by P equals ln Q plus 7. Calculate the elasticity of supply at P equals 110. This is the same as before. We need to find the Q first. And the Q is 3. One per point P per 110 per 3 times 1 per 1 is 110 per 3. The result is 0.7675. E is smaller than 1, so it's inelastic. That's all from me. Thank you.
Hi guys, I'm Audrey Salsabila Naufal from MB46 enter 2 with the student number 140122406A. And today we are gonna learn about mathematical finance and specifically about annuity and installment. Okay, we go right to the mathematical finance definition itself. Financial mathematics is a subset of applied mathematics that deals with financial markets. In financial mathematics material, it is also known as quantitative finance, which is a field of applied mathematics which is related to the mathematical modeling of financial markets. Financial mathematics expects us to be able to understand the problems of everyday life related to finance, for example, interest, bonds, and other financial problems. Next, what is the annuity and installment? So, annuity and installment. Annuity is a number of equal loan payments that are paid every certain period of time and consists of the interest part and installment part. So we can write annuity equal installment plus interest, or annuity as A equal AN plus BN. AN for the installment and BN for the interest, with N is a real number. From this annuity formula, it means that every time we make a payment by A, we pay installment and interest. The longer the payment, the greater the installment value and the smaller the interest rate. When the payment time is complete, we have also called all debts in the amount of all installment and all interest. From the form A equal AN plus BN, it means A equal A1 plus B1 equal A2 plus B2 equal A3 plus B3, and etc. Note, for finding the interest rate, B1 equal M times A. M times I. If the loan of M is repaid with an annual annuity system for n years with an interest rate of 1% per year and each annuity is the same, then AN plus 1 equal AN. AN plus 1 is AN plus 1 plus BN plus 1, and AN itself is AN plus BN. So AN plus 1 plus BN plus 1 is AN plus 1 equal AN plus BN minus BN plus 1. So we move BN right here into right there. Okay, so this is the step by step, and from all the steps we get the AN plus 1 equal AN plus AN times 1 plus I, and A2 equal A1 times 1 plus I, and A3 equal A2 times 1 plus A, and so on. AN equal A1 times 1 plus A in the power of n minus 1. So we found the formula AN equal A1 times 1 plus A plus I, in the power of n minus 1, or n minus 1 we can change into n minus k. So AN equal AK times 1 plus I in the power of n minus k. And this is for the exercise. A loan will be repaid with a monthly annuity system. If the amount of the annuity is 40,000 rupiah, determine first. The amount of the first installment in the first interest is 25,000 rupiah. And B, the fifth interest rate if the fifth installment is Indonesia dollar rupiah. B, the fifth interest rate if the fifth installment is 3,100 rupiah. And we're gonna do the exercise first for the A. The amount of the first installment in the first interest is 250,000 rupiah. So we can say A equal A1 plus B1. A is 400,000 equal A1, we find the A1, and B1 is 250,000 rupiah. And we change A1 equal 400,000 minus 200,000, 250,000. So A1 is 150,000 rupiah. Next, for the last question, the fifth interest rate if the fifth installment is 350,000 rupiah. So it has a same step. So it has the same step like A equal AN plus BN. So A equal A5 because this is the fifth interest and fifth installment. So A5 plus B5. So A is a 400,000 equal A5. Fifth, we find A5 plus the fifth installment is 315,000. Yay! So the A5 is 400,000 minus 315,000. So the A5 is 85,000 rupiah. Alright, that's all for my presentation. I'm sorry if I have any mistake. Thank you for your attention. Bye. See you next time.
Hello everyone, my name is Rafarrelia Syifa Adrina with my student ID number 14012224305. And right now I'm going to explain about matrix. The definition of matrix. Matrix is a set of numbers arranged in rows or I and column or J so as to form a rectangular array. The numbers are called the elements. So consider this is the A matrix. So this one here are called the elements of the matrix. And the horizontal lines here, it calls rows of the matrix, and the vertical line here called the column of the matrix. Next, types of matrix. There are 7 types of matrix. First, column matrix. Column matrix is a matrix in which all the elements are in a single column. It consists of only one column and multiple rows. Second, row matrix. Row matrix is a matrix in which all the elements are in a single row. It consists of only one row and multiple columns. Third, square matrix. Square matrix is a matrix with the same number of rows and columns. So if the row of the matrix only consists 2, the column will also consist 2. But if the rows consist of 3, the column will also consist of 3. Fourth, zero matrix. Zero matrix is a matrix that has all the elements equal to 0. 5, identity matrix. Identity matrix is a given square matrix of any order which contains on its main diagonal elements with value of 1, while the rest of the matrix elements are equal to 0. 6, triangle matrix. There is 2, upper and bottom. Upper triangle matrix has all the elements below the main diagonal as 0, and bottom triangle matrix has all the elements upper the main diagonal as 0. And the last one, symmetrical matrix. Symmetrical matrix is a square matrix that is equal to its transpose. So if we transpose this matrix, it will also the same as its matrix. Next, minor, cofactor, and adjoint matrix. First, minor. The minor of matrix is for each element of matrix and is equal to the part of the matrix remaining after excluding the row and the column containing that particular element. For the example, here's the B matrix. If we want to find the minor of the first row and the first column of the B matrix, we should hide the first row here and the first column. So the elements of the B matrix will only contain E, F, H, and I. Like this. After this, we should multiply the E and I minus H and F. So it will be like this. E times I minus H times F. And so on until the last row and column of the matrix. Next, cofactor. Cofactor of an element within the matrix is obtained when the minor M, row, and column of the element is multiplied with -1 rank I plus G. And here's the formula of the cofactor. Last, adjoint matrix. The adjoint of a square matrix is defined as the transpose of the cofactor elements of matrix. And here's the formula. Example, find the minor, cofactor, and adjoint of the matrix A below. So from the question, find the minor elements of matrix A. First, find the minor of row 1, column 1. To find the minor elements of row 1 and column 1, we should hide the first row and the first column. So it will be 5, 4, 1, and 2. And then 5 times 2 minus 4 times 1. It will be 10 minus 4, 6. Then minor row 1, column 2 will be row 1, column 2. So it'll be 2 times 2 minus 3 times 1 will be 4 minus 3. So it will be 1. And then minor row 1, column 3. Row 1, column 3. 2, 3, 5, and 4. 2 times 4 minus 3 times 5. 8 minus 15 will be minus 7. And so on to the next row and column.
row 2, column 3. And then next, minor column, and then next, minor row 3, column 1. Minor row 3, column 2. One minus 6 will be minus 5. And the last one, minor row 3, column 3. Okay, so this is the minor elements of matrix A. So the last question is find the cofactor. And this is the formula of the cofactor. So the cofactor of first row and first column is minus 1, rank 1 plus 1 times 6. It will be 6. Row 1, column 2, minus 1, rank 1 plus 2 times 1. Minus 1. A, rank 1. Row 1, column 1 equals to minus 1, rank 1 plus 3 times minus 7 will be minus 7. A, row 2, column 1, it will be minus 1, rank 2 plus 1 times minus 4, it will be 4. Oh, I'm sorry. Oh, yes. It's right. And then row 2, column 2, minus 1, rank 2 plus 2 times minus 7 will be minus 7. A, row 2, column 3, minus 1, rank 2 plus 3 times minus 8 will be 8. A, row 3, column 1 will be minus 1. 1 times minus 11, so it will be minus 11. A, row 3, column 2 will be 5. And last, row 3, cofactor of row 3, column 3, minus 1, rank 3 plus 3 times minus 3 will be minus 3. So from there, we can find the cofactor of A will be 6, minus 1, minus 7, 4, minus 7, 8, minus 11, 5, and minus 3. So this is the cofactor. So from this, we can find the adjoint. From adjoint matrix of A could be the cofactor of A transpose. So transpose means you change the row into column and the column into row. So will be 6 stay here, 4, minus 11, minus 1, minus 7, and then minus 7, 5, 8, and minus 3. So this is the adjoint matrix of A.
That's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.